So we're going to tell you a little bit about the history of Office security, our approach to securing Office, and we'll give you some demos of both internal tools and some protections that we're delivering in the next version of Office, Office 2010. So the history here is our oldest threat was macroviruses. So you got like a Word document and you may have had some malicious macros in it, and if you enabled those macros, that macro document could go and infect other Word documents, and before you knew it, all the documents in your hard drive were infected with this macro virus, and you would give those files to other people who may also have gotten infected. So that was a little bit of a problem. The antivirus definitely started detecting that, and we made those scenarios a little bit better so that people understood some of the threats around macroviruses. Then around 1999, there were a rash of Outlook attachment issues and ActiveX repurposing issues. Does anybody remember the first big Outlook attachment issue, what the name of that virus was? Oh, a lot of people seem to love my presentation already, but that is not the answer I was looking for. There's something that happens before I love you. Melissa. Yeah, so Melissa happens in, I think, March of 99, and then about a year later, the I love you virus happens. So does anybody see a lot of those viruses happening today? Those attachment viruses? No, you don't. Do you know why? Users are smarter. That was one comment. One of the things that we did was we decided that executable attachments would not be allowed. So what happened in those cases of the macro or the Outlook attachments is you received something like a VBS file, and the user said, oh, somebody loves me, they want to open that thing, or I want to see the picture, or whatever. So they click on that VBS file, and that VBS file then runs whatever code it wants on the user's machine, and then it checks out that Outlook address book and sends it to all their friends, right? So instead, what we decided is that there were security prompts when the user received these VBS attachments. And they said, yes, I want to see this thing even though you're warning me about security. So we decided to block those things so the user does not have a choice. That's somewhat of an interesting choice. You'll see later in this presentation how we talk about the prompts not always being the best solution for security. Then prior to 2006, we saw very few malformed document attacks. And when I talk about malformed document attacks, I'm talking about fuzzing type issues like buffer overruns, double freeze, use of uninitialized memory. And then this happened. Guy finds a brand new Excel vulnerability. And what do you do when you find a brand new Excel vulnerability? You post it on eBay with your old socks and all kinds of other stuff, right? So this happened, and it drew a lot of attention that there may be some interesting vulnerabilities in Office. This happens at the end of 2005. And so I think this really drew a bullseye on Office, and people started to think hard about maybe I too can find some zero-day type bugs in Office. And shortly after, you start to see things like this, targeted attack using an unpatched Excel flaw. But it doesn't stop with Excel. The next one, we have a Word problem. Not to be let out, we have another Excel problem. We have a PowerPoint problem. The Excel one, we actually end up releasing a mitigation tool because we have these problems. And then, more Excel problems. And this goes on for a while. And when this happens, it is not fun at all. It's really not fun. There were like no jokes about this. Now, there are people in the audience, kind of joking and saying stuff like that. But when this happens to your product, you feel terrible. It's not fun. So this is how we're organized. There's a few centralized security teams, like the MSec team that drives the overall security process for Microsoft. They work with an Office Trustworthy Computing team. The Office Trustworthy Computing team is the team that I work on, and we drive the SDL and the overall security goals and processes across all of the Office applications. We have security contacts on each of the product teams. So each of the product teams have a developer, tester, and program manager whose job it is to be a security contact. Their job is to tell us about security problems that they feel like might be in their application and to work with us to help and mitigate those issues, and then also to train all of the developers, testers, and program managers on that product team so that those people that are building the features are knowledgeable enough to build it, code it, and test it for a security standpoint. And then the other team we have is the Office SE team called CAPES, and then they work with any type of MSRC case that comes in. They work with the product teams to issue those patches. So in securing Office, we didn't want to just take one approach and say, hey, we have a bunch of fuzz bugs, let's just go after them. We wanted to look at this and lay our defenses, and the way that we do that is in 4 layers. First, we try to harden the attack surface, we reduce the attack surface, we mitigate exploits, and we try to improve the user experience, and I'll dig into each of those now. So in hardening the attack surface, we certainly are SDL compliant, and in many places will exceed the SDL. We use things like OACR, which wraps things like FXCOP and prefast. These are code review tools. And then that code, those reports go directly to the developers that wrote that code so that they can fix that and learn so that they don't make those sorts of mistakes again. We'll also do things like when we see a common theme, like integer overruns are a common theme that we saw. We'll do things like create a code library called SafeInt to help developers write more secure code in an easier way. In a project like Office, you have many parsers, which we'll see in a minute or so, but you may also have duplicates of parsers parsing the same file format. So what we can do there is we can harden one of those parsers and reuse it in other places instead of trying to secure many parsers that do the same thing. And then the last piece that we do in hardening our attack surface is we do a lot of intensive fuzzing, and that's done in a distributed manner. So like I mentioned, we have a rather large attack surface from the file format standpoint. We have over 300 file formats. And many of these file formats are not obvious at first. For example, WPD, when you look at the file extension, you say, oh, that's a file format. It turns out that there's actually 3 file formats within that extension. In many places, we'll have smarter, specialized fuzzers that know about the file format and ways to manipulate that in a specific way that understands the spec. And then one of the things that we found is very much in line with what was talked about in last year's BlueHat is different fuzzers find different bugs. And the more you fuzz, the more bugs you find. So we want to be able to put in as many different fuzzers as possible, and we want to fuzz as long as possible, as many iterations as we can. So one of the ways that we did to accomplish this is we built a distributed file fuzzing framework, and that was built by David. So one of the goals in that model that I talked about with the organization of Office is where we get every person thinking about security. We come up with interesting solutions that may not be thought about by the centralized security team. And in this case, David works on the access team, and he thought of this solution. So when you have this many file formats, you have some interesting things when you're trying to manage the SDL compliance around fuzzing. So each team has a subset of those file formats that are supported, and it's unclear from an overall standpoint how many iterations have been completed by each team and on each format. Machine logs often duplicate the same crash across machines and across runs and things like that. So it becomes time consuming to go in and understand that. And best practices that are discovered by one team may not be shared with other teams. And so you may have some people learning some really interesting efficiency things, but other people are not being able to take advantage of that. One of the other big problems we had was machine resources. What we were doing is we were leveraging machines in testers' offices. And so testers would manually configure